Hi learners! On this video lesson, you will learn how to find the volume of cones or cone-shaped objects. Determining the volume will be demonstrated and explained in details to let you understand the concept easily. Real-life examples and application are shown, thus making the concept relatable and meaningful. Strategies in analyzing and solving problems related to the topic are demonstrated to let you gain an understanding on how these are done so that you will be able to successfully answer geometry problems similar to these in the future. If your lesson is on solid geometry, particularly on cones and their volumes, or if you have an assignment on this topic, or if you are preparing for tests in math or tests in geometry in particular, or you're someone who's interested in learning math, then this video is for you. Where do we see cones and cone-shaped objects, and what are some real-life examples of this? The truth is, a lot of these cones and cone-shaped objects are around us. Take, for instance, the ice cream cones, party hats, candies, sharpened pointed pencil, Christmas trees, rooftops of some buildings and structures, traffic cones, carrots, pine trees, and even some volcanoes have conic shape. Mayon volcano, for one, is dubbed as the perfect coned volcano. How about you learners? Can you name some? Okay, as you see here, a cone is a three-dimensional closed surface or solid having a circular base and a lateral curved surface connecting the base and the vertex or apex. On this video lesson, we will consider right circular cones only. These are the cones whose line connecting the apex and the center of the base forms a right angle with the base. The distance from the apex to the center of the base is the height of the cone. There's another height here, the slant height. This is the height of the curved surface. Another important element of the cone is the radius of its base. This is the distance from the center of the base to any point on the circumference of the circular base. How do we get the volume of the cone? Before we go there, let us recall what a cylinder is. Here is a cylinder with height h and radius r. Its volume is pi r squared h, where r is the radius of its base and h is the height of the cylinder. The part of the formula which says pi r squared is the area of the circular base. Now look at these learners. When 2/3 of the portion of the cylinder is chipped off like this, leaving the same base and height of the original cylinder, what is left is a cone having the volume 1/3 that of the original cylinder. Thus, the volume of the cone is 1/3 pi r squared h, where r is the radius of the circular base and h is the height of the cone. Always remember these learners. You need to know the radius of the circular base and the height of the cone for you to be able to determine its volume. The unit of measure for its volume is cubic units, like cubic centimeters, cubic inches, cubic feet, cubic meters, etc. The justification to the formula for the volume of the cone could be done by conducting an experiment to show that the volume of the cone is only 1/3 the volume of the cylinder, having the same base and the same height. You can demonstrate this in class using water and two containers. One container having the shape of the cone and the other one a cylinder. Just make sure that the containers, the cone and the cylinder, have congruent bases, same shape and area, and they must have the same height. Okay, let us solve this sample problem so you will know how it is done. Here's the problem. Clark would like to hold an ice cream party in his class. For the party, his mom and dad have to purchase ice cream and regular-sized ice cream cones with a radius of 1 inch and a height of 4 inches as shown. Part 1. How much ice cream to the nearest tenth of a cubic inch can one ice cream cone hold? Option A, 4.1 cubic inches. Option B, 4.2 cubic inches. Option C, 12.5 cubic inches. Option D, 12.6 cubic inches. Part 2. Clark has 40 classmates and he wants to offer to each of his classmates a second serving of the ice cream during the party. How many gallons of ice cream would his mom and dad purchase for his ice cream party? Note that 1 gallon has 231 cubic inches of ice cream. Option A, 1/2 gallon. Option B, 1 gallon. Option C, 1.5 gallon. Option D, 2 gallons. As usual, we begin by reading the whole problem and may read it several times when needed to know what we're looking for, to determine what are given, and to figure out how the given information help find what we're looking for. Okay, what are asked in the problem, learners? Here, we're asked to find 2 things. First, we're to find how much ice cream to the nearest tenth of a cubic inch can one ice cream cone hold. Second, we're to determine how many gallons of ice cream should Clark's mom and dad buy for his ice cream party with his 40 classmates and of course himself. What are given? We're given a figure of the ice cream cone with dimensions. The problem also states that Clark has 40 classmates and he wants to offer his classmates a second serving of the ice cream. Okay, so we will do part 1 first. Here, we're asked to find how much ice cream to the nearest tenth of a cubic inch can one ice cream cone hold. This is the same as finding the volume of the ice cream cone. Can you follow, learners? So, we will start with the formula for the volume of the cone. Let us have the formula. Now, let us identify what each dimension on the figure represents so that it will be easy for us to do the substitution later. Now, plugging in the values, we have multiplying 1 inch to itself gives us 1 square inch. Multiplying 1 square inch and 4 inches gives us 4 cubic inches. Multiplying 4 cubic inches and pi gives us 12.566 cubic inches. Dividing 12.566 cubic inches by 3 gives us 4.189 cubic inches. Rounding off to the nearest cubic inch gives us 4.2 cubic inches. So, what is our answer, learners? Is it option A, option B, option C, or option D? Okay, so the answer is option B. The amount of ice cream that one ice cream cone can hold is 4.2 cubic inches. That was easy. Okay, we move on to part 2. Here, we're to determine how many gallons of ice cream should Clark's mom and dad buy for his ice cream party with his 40 classmates. Of course, Clark has to add himself to the group. So, all in all, there will be 41 people in the party. Can you follow, learners? Remember that he wants to offer a second serving to each of his classmates. This means multiplying 41, the number of people in the class, by 2 to get the number of servings of ice cream that he has to prepare. Can you still follow, learners? And that is 82 servings. Clark will also be getting a second serving. From part 1, we found that one ice cream cone holds 4.2 cubic inches of ice cream. That means each serving contains 4.2 cubic inches of ice cream. Since Clark has to prepare 82 servings, the amount of ice cream needed would be 82 times 4.2 cubic inches. Do you agree, learners? And this is 344.4 cubic inches. So Clark needs 344.4 cubic inches of ice cream for the class of 41 people. Now, 1 gallon of ice cream contains 231 cubic inches of ice cream. Will 1 gallon be enough? Okay, so no, for Clark needs 344.4 cubic inches of ice cream for the whole class. Let us see. A gallon has 231 cubic inches of ice cream. Then, half gallon has 115.5 cubic inches of ice cream. Do you agree? Adding 231 cubic inches and 115.5 cubic inches gives us the amount for the 1.5 gallon of ice cream in cubic inches. And this is 346.5 cubic inches. Again, how much ice cream in cubic inches does Clark need for the whole class? Okay, so Clark needs 344.4 cubic inches of ice cream for the class. So, how many gallons of ice cream would his mom and dad purchase for his ice cream party? What is our answer here, learners? Is it option A, option B, option C, or option D? Okay, so the answer is option C. So, Clark's mom and dad have to purchase 1.5 gallon of ice cream for his party. That was again easy. There you are, learners. I hope you acquired lots of learnings in today's video. Let us summarize what we have learned today. We have learned that, first, a cone is a 3D closed surface or solid having a circular base and a curved surface connecting the base and its topmost part called the apex. Second, the volume of the cone is 1/3 pi r squared h, where r is the radius of the circular base and h is the height of the cone. Third, the unit of measure for its volume is cubic units like cubic centimeters, cubic inches, cubic feet, cubic meters, etc. Fourth, when solving a problem, you must read it and may read it several times when needed to know what you're looking for, to determine what are given, and to figure out how the given information helps find what you're looking for. Fifth, when a figure is given, make use of it and modify when needed. It is there to help you analyze and solve the problem. There you are, learners. Hope this video helps. That's it for now. If you have any questions, leave a comment below and don't forget to like, subscribe, and share this video to your peers so others will learn too. Bye.